All right, welcome. So I've got a solid half hour here. So let's make a big dent in the Nvidia certification. So this is part 11, and I'm reading about enhancing data movement with GPU Direct. This is the beginning of the networking section. So time on the clock, about 3 minutes. Hopefully it will take that long, but usually it takes quite a bit longer. All right, so this is Nvidia GPU Direct, enhancing data movement and and access for GPUs. Whether you are exploring mountains of data, researching scientific problems, training neural networks, or modeling financial markets, you need a computing platform with the highest data throughput. GPUs consume data much faster than CPUs, and as the GPU computing horsepower increases, so does the demand for I/O bandwidth. Nvidia GPU Direct is a family of technologies, part of Magnum I/O, that enhances data movement and access for Nvidia data center GPUs. Using GPU Direct, network adapters and storage drives can directly read and write to/from GPU memory, eliminating unnecessary memory copies, decreasing CPU overheads, and reducing latency, resulting in significant performance improvements. These technologies, including GPU Direct Storage, GPU Direct Remote Direct Memory Access (RDMA), um, GPU Direct Peer-to-Peer (P2P), and GPU Direct Video, are presented through a comprehensive set of APIs. GPU Direct Storage, a direct path between storage and GPU memory. As AI, HPC, and data analytics datasets continue to increase in size, the time spent loading data begins to impact application performance. Fast GPUs are increasingly starved by slow I/O input-output, the process of loading data from storage to GPU memory for processing. GPU Direct Storage enables a direct data path between local or remote storage, such as NVMe or NVMe over Fabric, NVMe-OF, and GPU memory. It avoids extra copies through a bounce filter in the CPU's memory, enabling a direct memory access (DMA) engine near the NIC network interface card, or storage to move data on a direct path out of the GPU memory, all without burdening the CPU. GPU Direct RDMA, direct communication between NVIDIA GPUs. Remote Direct Memory Access (RDMA) enables peripheral PCIe devices direct access to GPU memory. Designed specifically for the needs of GPU acceleration, GPU Direct RDMA provides direct communication between NVIDIA GPUs in remote systems. All right, we need extra time on the clock here. This eliminates the system CPUs and required buffer copies of data via the system memory, resulting in 10x better performance. GPU Direct RDMA is available in CUDA Toolkit. Contact networking vendors to download any third-party drivers that provide support for GPU Direct RDMA. So we've got these drawings here. So this is the PCIe switch, and then and so here's the memory. So without GPU Direct Storage, we see we've got a different line here. So we've got PCIe, and then we've got the bounce buffer. So we can see there's extra communication. It's not direct, right? So there's extra communication to the system memory, requiring this bounce buffer. But with it, you don't need the bounce buffer at all. So let's get some more information about this from ChatGPT, because I'm not familiar with what a bounce buffer is. It sounds like it could be relevant.
The image you provided shows two diagrams comparing data transfer with and without GPU direct storage. Diagram without GPU direct storage. Data flow. Data is read from NVMe storage. Data passes through the CPU. Data is then transferred to the system memory. Finally, the data moves from system memory to the GPU. Components. NVMe storage. CPU. System memory. GPU. PCIe switch. Diagram with GPU direct storage. Data flow. Data is read from NVMe storage. Data bypasses the CPU and system memory. Data is directly transferred to the GPU via the PCIe.
So what is a bounce buffer?
A bounce buffer is a memory buffer used as an intermediate storage area during data transfer operations. It is primarily used when direct memory access (DMA) from the source to the destination is not possible due to hardware or software constraints. Here's a detailed explanation of its role and functionality. Purpose of bounce buffer. Compatibility. It helps in situations where the hardware devices involved in the transfer do not support direct memory access to each other's memory spaces. Data alignment. It ensures that the data is properly aligned and formatted before being passed between different types of memory or devices. Overcoming limitations. It can be used to handle data transfers when direct paths are unavailable or impractical, ensuring data integrity and system stability. How bounce buffer works. Data transfer initiation. When data transfer is requested from an NVMe storage to a GPU, but direct access is not possible, the data is first copied to the bounce buffer. Intermediate storage. The bounce buffer temporarily holds the data. Secondary transfer. The data is then transferred from the bounce buffer to the target device, e.g., GPU. In the context of your diagram, without GPU direct storage, the bounce buffer is likely used in the system memory to temporarily hold data read from NVMe storage before it is transferred to the GPU via the CPU. With GPU direct storage, the bounce buffer is not needed because the data transfer happens directly between NVMe storage and the GPU, bypassing the CPU and system memory. Advantages. Increased efficiency. By allowing direct transfers, GPU direct storage eliminates the need for bounce buffers, reducing latency and CPU overhead. Improved performance. Direct transfers can significantly speed up data-intensive tasks, especially in high-performance computing and AI workloads. If you have any more specific questions or need further clarification, feel free to ask. The new image shows a comparison of data transfer methods between two GPUs using CONNECDX adapters with and without GPU direct RDMA, remote direct memory access. Diagram explanation. Without GPU direct RDMA, data flow, data originates from the GPU. It passes through the CONNECDX adapter. The data goes through the PCIe switch. Data is transferred to the CPU and then to system memory. Finally, the data is sent from the system memory back through the PCIe switch and CONNECDX adapter to the second GPU.
All right, well, we're at the 4-minute mark, and that's extra time, and it was only supposed to take 3 minutes, so well over double, so let's just try to get the reading done here. All right, so GPU direct storage resources. This I don't think is part of what's meant to be read. Other innovations in GPU direct, I think this matters to read. GPU direct for video. It offers an optimized pipeline for frame-based devices such as frame grabbers, video switchers, HD SDI capture, and camera link devices to efficiently transfer video frames in and out of Nvidia GPU memory on Windows only. And then finally, GPU direct peer-to-peer enables GPU to GPU copies as well as loads and stores directly over the memory fabric, PCIe NVLink. GPU direct peer-to-peer is supported natively by the CUDA driver. Developers should use the latest CUDA toolkit and drivers on a system with 2 or more compatible devices. Perfect. All right, so on to the next one. It should take 4 minutes, but as we've seen, in reality, it'll take a lot longer than that. All right, so this is the Nvidia Spectrum Ethernet platform. Explore innovative, efficient Ethernet solutions for accelerated AI and cloud. Complete Ethernet solutions from host to switch. With Nvidia Spectrum, experience industry-leading Ethernet performance, availability, and ease of use across a wide range of applications, including cloud computing, data storage, AI, and more. Nvidia Spectrum Ethernet is an end-to-end platform that includes Spectrum switches, ConnectX network interface cards, NICs, Delta View DPUs. I don't know what DPUs are. So a DPU is a data processing unit, and Super NICs, LinkX cables, and networking software. The new Nvidia Spectrum X networking platform featuring Spectrum SN5600 switches and Bluefield 3 SuperNICs, is the world's first Ethernet, and it's Ethernet, that's important, fabric built for AI, accelerating generative AI performance. So you don't necessarily need to learn InfiniBand because Ethernet is being developed for this use case. Nvidia supercharges Ethernet networking for generative AI. Spectrum X, adopted by cloud service providers, GPU cloud providers, and enterprises. Broad system maker support extends Nvidia networking's reach to every market. Spectrum switch systems. The Nvidia Spectrum Ethernet switch family includes a comprehensive switch and software portfolio spanning 1 gigabit Ethernet to 800 gigabit Ethernet. Nvidia Spectrum switches are ideal for both building AI fabrics, connecting Nvidia GPUs, and connecting end-to-end cloud data center networks. Combining Spectrum switches with Nvidia Cumulus Linux, Nvidia Pure Sonic, Nvidia NetQ validation toolset, and Nvidia Air simulation platform delivers the performance and features that every data center needs. So we can learn more there. So this is an Ethernet switch as opposed to InfiniBand. Then we have Bluefield data processing units, DPUs. The NVIDIA Bluefield DPU ignites unprecedented innovation for modern data centers, delivering a broad range of advanced networking, storage, and security services for complex compute and AI workloads, virtual machines, containers, and bare metal servers in enterprise and cloud. By combining the industry-leading NVIDIA ConnectX network adapter with an array of ARM cores, Bluefield offers purpose-built hardware acceleration engines with full programmability through NVIDIA DOCA. All right, so next is NVIDIA SuperNICs. NVIDIA Ethernet SuperNICs deliver powerful networking capabilities for AI factories and cloud data centers. So designed for network-intensive, massively parallel computing, these SuperNICs accelerate GPU to GPU communication, ensuring high bandwidth, low latency data transfers and enhancing AI performance and scalability. Integrated with NVIDIA Spectrum X, they form a critical component of modern AI infrastructure, driving unprecedented efficiency and speed in AI applications. So when over time, that's okay as long as I'm not going like hours and hours over time. ConnectX NICs. The industry-leading NVIDIA ConnectX family of intelligent network adapters offers the broadest and most advanced hardware acceleration engines running any workload at any scale. ConnectX enables the highest ROI and lowest TCO. So ROI is rate of return, TCO total cost of ownership for cloud data centers, enterprise environments, and SDN and network functions virtualization NFV for telecommunications companies. Then we have LinkX Ethernet cables and transceivers. NVIDIA LinkX cables and transceivers are designed to maximize the performance of high-performance computing networks, delivering high bandwidth, low latency, and highly reliable connections between Ethernet elements. All right, and we got more to read here. So Ethernet enhanced capabilities. The first one is NVIDIA Spectrum X networking platform. The Spectrum X networking platform, featuring Spectrum 4 switches and Bluefield 3 SuperNICs, is the world's first Ethernet fabric built for AI, accelerating generative AI network performance by 1.6 times over traditional Ethernet fabrics. So they've built basically a new Ethernet. Industry-leading ROCE performance. NVIDIA Spectrum Ethernet switches, NICs, SuperNICs, and DPUs provide best-in-class enterprise-grade RDMA, which is remote data memory access. remote direct memory access. So that D is important because with it being direct, you don't have to have a bounce buffer. So best in class enterprise grade remote direct memory access over converged Ethernet acceleration, ROCE, which delivers unmatched throughput and low latency connectivity for scale out distributed applications. All right, so next is Nvidia DOCA software framework. The Nvidia DOCA software development kit enables developers to rapidly create applications and services on top of Nvidia Bluefield DPUs, leveraging industry standard APIs. And then zero trust protection, from platform security to accelerated crypto and distributed firewalls. Nvidia Bluefield SuperNICs and DPUs provide software-defined hardware accelerated security engines for zero trust protection across every layer of the stack. The Spectrum X networking platform is now available from these partners: Dell, Enterprise, Lenovo, Super MICR. Notably absent is Cisco. All right, we have the option to read an entire white paper, but we're already 3 minutes over the predicted time, so this would take an hour to read. All right, so on to the next one. What is a DPU? It would have been nice if that one was first, but it's good that it's going to be finally revealed. So this is 4 minutes. I have plenty of time for that, so we're going to start the clock and figure out what is a DPU. And what's the difference between a DPU, a CPU, and a GPU, written in 4 years ago. What is a DPU? Specialists in moving data in data centers, DPUs, or data processing units, are a new class of programmable processor that will join CPUs and GPUs as one of the 3 pillars of computing. Of course, you're probably already familiar with the central processing unit, CPU. Flexible and responsive, for many years, CPUs were the sole programmable element in most computers. More recently, the GPU, or graphics processing unit, has taken a central role. Originally used to deliver rich real-time graphics, their parallel processing capabilities make them ideal for accelerated computing tasks of all kinds. Thanks to these capabilities, GPUs are essential to artificial intelligence, deep learning, and big data analytics applications. Over the past decade, however, computing has broken out of the boxy confines of CPUs and servers, with CPUs and GPUs powering sprawling new hyperscale data centers. These data centers are knit together with a powerful new category of processors. The DPU has become the third member of the data-centric accelerated computing model. This is going to represent one of the 3 major pillars of computing going forward. Nvidia CEO Jensen Huang said during a talk earlier this month. The CPU is for general purpose computing, the GPU is for accelerated computing, and the DPU, which moves data around the data center, does data processing. What is a DPU? System on chip that combines industry standard high performance software programmable multi-core CPU, high performance network interface, flexible and programmable acceleration engines. CPU versus GPU versus DPU. What makes a DPU different? A DPU is a new class of programmable processor that combines 3 key elements. A DPU is a system on a chip, or SoC. Oh, that's interesting. A system. So it's a whole system on a chip, and it combines 3 components. individual components that make up the system. So the first one is an industry standard high-performance software programmable multi-core CPU, typically used on the widely used ARM architecture, tightly coupled to the other SoC components. Number two, a high-performance network interface capable of parsing, processing, and efficiently transferring data at line rate or the speed of the rest of the network to GPUs and CPUs. Number three, a rich set of flexible and programmable acceleration engines that offload and improve applications performance for AI and machine learning, zero trust security, telecommunications, and storage, among others. All these DPU capabilities are critical to enable an isolated bare metal cloud-native computing platform that will define the next generation of cloud-scale computing. So you can watch the 4-hour keynote speech. Well, it's 13 minutes, so it's not that bad. Sorry for anyone who has epilepsy for that. I'm not sure what's going on there. But that would definitely, yeah. So the next section we'll get to, but we need some extra time here. All right, so the next section is DPUs incorporated into smart NICs. A DPU can be used as a standalone embedded processor, but it's more often incorporated into a smart NIC, a network interface controller. Well, I said card, but controller is probably more accurate. Used as a critical component in a next generation server. Other devices that claim to be DPUs miss significant elements of these three critical capabilities. And remember, yeah. Okay. So DPUs can be used as a standalone embedded processor, but they're more often incorporated into a smart NIC, a network interface controller used as a key component in a next generation server. For example, some vendors use proprietary processors that don't benefit from the broad ARM CPU ecosystem's rich development and application infrastructure. Others claim to have DPUs, but make the mistake of focusing solely on the embedded CPU to perform data path processing. So the other ones don't benefit from a broad ARM CPU ecosystem's rich development and application infrastructure. So not enough time for watching this hour-long podcast. So let's try to wrap this up here. A focus on data processing. That approach isn't competitive and doesn't scale because trying to beat the traditional x86 CPU with a brute force performance attack is a losing battle. If 100 gigabit per second packet processing brings an x86 to its knees, why would an embedded CPU perform better? Instead, the network interface needs to be powerful and flexible enough to handle all network data path processing. The embedded CPU should be used for control path initialization and exception processing, nothing more. At minimum, there are 10 capabilities in the network data path acceleration engines need to be able to deliver. And this probably will be on the test. Number 1, data packet parsing, matching, and manipulation to implement an open virtual switch, OVS. Number 2, remote direct memory access, data transport acceleration for zero touch ROCE. I forget what ROCE stands for. All right, that's the only time it's mentioned. GPU direct accelerators to bypass the CPU and feed networked data directly to GPUs, both from storage and from other GPUs. TCP acceleration, including RSS, LRO, checksum, etc. Network virtualization for VXLAN and Geneve overlays, and VTEP offload. Traffic shaping, packet pacing accelerator to enable multimedia streaming, content distribution networks, and the new 4K/8K video over IP, RiverMax for ST2110. Number 7, precision timing accelerators for telco cloud RAN. I'm not sure what RAN stands for here, such as 5T for 5G capabilities. This does not bode well for passing this test. So radio access network. Okay, that makes sense. Yeah, radio. 5G's radio. Number 8, crypto acceleration for IPsec and TLS performed inline. So all other accelerations are still operational. And a crypto here does not mean cryptocurrency. It means that the communications are encrypted with security protocols that makes it more secure, as far as I understand. And number 9 is virtualization support for SRIOV, VirtIO, and Paravirtualization. And number 10 is secure isolation, root of trust, secure boot, secure firmware upgrades, and authenticated containers, and application lifecycle management. These are just 10 of the acceleration and hardware capabilities that are critical to being the answer yes to the question, what is a DPU? So yeah, it's going to be on the test. I feel like if there's anything I should make flashcards of, it's probably this. So what is a DPU? This is a DPU. It's a it looks just like a CPU, and it does contain a CPU. Many so-called DPUs focus on delivering just one or two of these functions. The worst try to offload the data path in proprietary processors. While good for prototyping, this is a fool's errand because of the scale, scope, and breadth of data centers. All right, so that's it. So the next, now this is 9 minutes, which for me means probably 20 at least. So yeah, I got to end the video here. So yeah, good progress. Very, very nearly done with this. Once I'm done reading this, I'll go back through and make some Anki flashcards. I'll schedule the test and I'll take the test. So stay tuned for that. Thanks for watching. See you in the next one.